So section 3.4 is going to give us an idea about why our atomic mass has a decimal, because we know we can't have portions of subatomic particles. So it's because of things called isotopes, and that's what this section is on. So what is an isotope? An isotope is the atoms of the same element, so identical elements, but with a different number of neutrons. Because you have a different number of neutrons, and remember, neutrons have the heaviest mass of all the subatomic particles, that's going to change slightly the overall mass of the element. You still have to have the same number of protons and electrons. You cannot change those. Only the number of neutrons can change. Most elements have at least one isotope, not all, but it's common to have at least one isotope. Tin, SN, actually has the most naturally occurring isotopes with 10. So there's two formats for looking at an isotope, two different ways to write it. You can have hyphen notation or you can have nuclear notation. Either way is representing the same thing. In hyphen notation, you have the element's name and then you have a number, a whole number. That whole number is representing the element's atomic mass, which is protons plus neutrons. In nuclear notation, you have the element's atomic symbol, and then to the left, there are two stacked numbers. The top number represents the atomic mass. The bottom number represents the atomic number. So if you look at these, hydrogen has three isotopes. The first isotope, hydrogen 1, there is one proton, the atomic number 1, and there's one electron. Okay, so that's the atomic mass. And notice there are no neutrons. So the atomic mass is 1 from one proton, and the atomic number is 1 because there's one proton and there's one electron. They're the same number. If you look at hydrogen 2, in the nucleus, there's one proton and there's one neutron. Proton plus neutron is atomic mass. So one proton plus one neutron equals 2. So the atomic mass is now 2. But the atomic number has to be the same. There is still only one proton. There is still only one electron. If you look at hydrogen 3, there are now one proton plus two neutrons in the nucleus. 1 plus 1 plus 1 is a total mass of 3. So now we have a mass of 3, but we still have atomic number of 1 because there's still only one proton and one electron. So the only thing that can change with isotopes is how many neutrons, and therefore that changes our mass. So if you actually calculate this, so if we take 1 for the mass of hydrogen 1 plus 2, the mass of hydrogen 2, plus 3, the mass of hydrogen 3, and divided by 3, we get an average mass of 2. If there was a decimal there, that's how you get the decimal for the average atomic mass. And there are more isotopes than what I'm telling you, but that's how they get that. So let's actually examine nuclear notation a little clearer. So in nuclear notation, once again, you have an element symbol, a number on the top, and a number on the bottom stacked, always whole. Obviously, C represents the chemical symbol. The top number, whole number, represents the atomic mass, the number of protons plus neutrons, addition. And then the bottom number represents the atomic number, which is the number of protons and the number of electrons. They are equivalent. So, looking at these examples, try to fill it out. The atomic number is the bottom number. The atomic mass is the top number. So the atomic number for both of these is going to be 6. They're both carbon. The atomic mass for the first one is 12. The bottom one is 13. So remember, number of protons and number of electrons is equal to the atomic number So I'm going to have atomic number 6 protons, 6 electrons, and I'm going to have for this one 6 protons and 6 electrons because it's still carbon. To get the number of neutrons, I have to take the atomic mass minus the atomic number. So the atomic mass was 12, atomic number 6, I get 6 neutrons. The atomic mass here was 13, the top number, minus 6, I get 7 neutrons. And that makes sense because the only thing that changed was the number of neutrons. Those are isotopes. Okay, so try this one. So Ag is silver. So atomic number is the bottom number, 47. Top is 108. And these are always rounded just to make it look nice. The periodic table is not rounded. Okay, number of protons is equal to the atomic number. So 47. Number of electrons is equal to the atomic number. And then to get neutrons, I have to take the atomic mass minus the atomic number. What you get for that? 61. Okay. What if I ask you to write the nuclear notation? So write the nuclear notation for bromine 80. So Br is bromine. I'm going to have 2 numbers. The top number is the mass, the bottom is the atomic number. So looking at the periodic table, bromine's atomic number is 35. That cannot change. And here is the atomic mass I want to use. Just plop that in. If you look at the periodic table, it may be a little bit lower or rounded, but that's all you do. Just pop in the numbers. If you're looking at the periodic table, you would want to make sure this number is rounded. Don't give me a decimal. So the other thing is called hyphen notation. So for hyphen notation, you have the element name written out, and then a dash, a hyphen, and then a whole number. That whole number is representing the atomic mass, which is protons plus neutrons. You do not have the atomic number, protons and electrons equivalent in this type, or at least being represented. So try this. So helium is He. Go to your periodic table. What is the atomic number for He? It is 2. So it doesn't matter which isotope, it's still 2 because that's the atomic number. That is equivalent to the number of protons and the number of electrons. That cannot change. Using these numbers, these are the atomic masses. So helium-3's atomic mass is 3. Helium-4's atomic mass is 4. I find the number of neutrons by taking the atomic mass minus the atomic number. The atomic mass of 3 minus atomic number of 2 gives me 1. For helium-3, there's 1 neutron. And if I take helium-4's mass minus its atomic number, 2. Helium-4 has 2 neutrons. Once again, that's the only thing that should be different besides the mass, which comes because it's different neutrons. All right, what if I asked you to write hyphen notation? So write the hyphen notation for an element that contains 15 electrons and 15 neutrons. Well, we know that electrons is equal to the number of protons, which is also equal to the atomic number. Which element has an atomic number of 15? That is P, phosphorus. So you write out the element name, put a dash, and then I need to find the atomic mass, which goes here. Mass is equal to the number of protons plus the number of neutrons. Well, I have the number of neutrons here, and I have the number of protons here. So 15 plus 15 is 30. That is hyphen notation. So 2 types of isotopes being characterized by what's written with them, hyphen notation or nuclear notation. Either way, the atomic number, protons and electrons is always the same. The only thing that can change is mass, and that's because of the different number of neutrons. Always do whole numbers for no matter which version, hyphen or nuclear.